What's up, everybody? It is 2023, and shockingly, I am still not a software engineer, but today we're going to take a look at what it might look like to simulate an LED scoreboard using Python and Pygame. So I had a friend reach out to me asking if I could come up with some type of, basically some code or an application or whatever to create a scoreboard for his ping pong setup. And basically what that would entail is that there would be two halves of a screen similar to this, and you'd basically have a point on the left and a point on the right, and whoever gets to the desired score at first is deemed the winner. And so I was able to do that in Pygame really quickly, but it got me thinking, what about an LED screen? And so basically that's what today's video is going to be about. And I'm sure that there are things you can do with a Raspberry Pi and these adafruit screens that you see here in this picture and things like that that are already implemented in Python or other languages. But I basically decided to take it upon myself to really kind of figure out how you would draw to something like this screen here. So the first thing I wanted you to notice is that this is basically a 64 pixel wide and 32 pixel high screen. So it says 32 by 64 here, but if we were to use something kind of like 1980 or rather 1920 by 1080 as kind of like the 1080p resolution, it puts the width first. So I'm going to refer to the screen size as 64 by 32, even though it says the opposite right here. But what I wanted to kind of show you is the setup, which I basically have created, and it is just the repo that you see in front of us, which is the scoreboard-pixel repo. And I've cloned that locally. Of course, there's not a whole lot going on just yet, but we are going to go ahead and start adding files in VS Code. So within VS Code, we're going to have a couple of files that are not created at this point. But the first one, of course, is going to be our main.py file. And main.py is something that basically, we run, and then that controls our quote-unquote game logic. And we're going to be using the Pygame library for this scoreboard. So we're going to go ahead and import that, as well as a few other imports. And that's going to be ctypes, OS, and sys. So we're just going to do import ctypes, OS, Pygame, and sys. And ctypes basically is going to ignore any window scaling that we have going on. So we can go ahead and put a note here: maintain resolution regardless of Windows scaling settings. And if you've seen any of my other videos, you may have seen this, but it's basically just ctypes.windll.user32.set process DPI aware. And that's basically all there is to it. So now we're going to create a class game. And then we're going to have our def init function, which of course just takes self. And then we're going to have our general setup here. And again, this is pretty frequently occurring when doing a main.py for use with Pygame. So we're just going to do pygame.init. And we're going to set up our screen with self.screen equals pygame.display.setMode. And then we're going to have two variables here, a width and a height, which we have not set just yet. We'll do that in a moment. We're going to have a pygame.display.setCaption, and we're going to have a title string, which we have not set yet either. Then we're going to have a self.clock equals pygame.time.clock. And after we set that up, we can do a background image. And this is just going to be basically a black image that I will create in Photoshop here shortly. But that is just going to be self.bg_image equals pygame.image.load. And then we're going to have a bg image path, which we need to specify. And then we're going to create our scoreboard, which is going to instantiate, or rather create an instance of our scoreboard class, which we haven't created just yet. That's just going to be self.scoreboard equals scoreboard. And then we're going to have the starting score be 0 to 0. That makes sense. You would think that the scoreboard would start at 0, 0 at the beginning of a game. So then we're going to have our run function taking self as an input, and this is just going to be self.start time equals pygame.time.get ticks. And then we're going to have our while loop while it's true. Handle quit operation for event in pygame.event.get. We're basically just going to listen for a quit operation. So if event.type equals pygame.quit, we are going to pygame.quit and sys.exit. So now we're going to basically set up a listener for our two keys that are going to iterate the two sides of the screen. So if we go back over here, I was basically mentioning that I'm going to have one side be the left and one side be the right. And so basically I'm going to have two different keys control the scores for each side. And just for ease of demonstration, I'm going to use A for the left side and F for the right side. And of course you can change this however you want. Refer to the Pygame documentation to specify other keys, but I'm just going to use A and F. So I can go back to the code and I can basically have another event type that we're going to listen for. So that is just going to be elif event.type equals pygame.keyDown. And so now we're going to have some logic for our A and F keys. And that's just going to be if event.key equals pygame.k, which is key A. And basically we need to have some logic here that determines whether or not we can increment the score. So this will be a cooldown that we will have in our scoreboard class. But basically that will just be self.scoreboard.canIncrement. So if we can increment the score, then we'll go ahead and do that, right? And the way that we can do this is self.scoreboard.player1score plus equals 1. Then we're going to do a couple other things that we care about. So we're going to basically self.scoreboard.increment time. And this is going to allow us to have a cooldown. And we're just going to have pygame.time.get_ticks. And then finally, we're going to have a self.scoreboard.canIncrement equals false. And so this is going to have, you know, if you think about playing ping pong, you can only really score like once every, I don't know. I mean, it's probably like 5 or 10 seconds realistically, but I'm going to set this just to 1 second so you can't just spam this over and over and over again. It's just going to be kind of like a, I don't know, some type of protection against someone, you know, pushing the button over and over again and immediately winning the game. But we're also going to listen for the F key, which is going to be basically an elif event.key equals pygame.k_f for the F key, and self.scoreboard.canIncrement. Then we're going to do the same thing. I'm just going to copy and paste this in. And of course, this is going to be p2.score. And that is it for our key listeners. We do need to have basically a couple of I do want to keep track of when I start the game for a variety of reasons, but for now we'll just leave this as time variables. Self.startTime equals pygame.time.get_ticks. Cool. So now we basically need to draw our screen. And of course, this does not need to be commented. And when we draw our screen, we're just going to put this in the display. Self.screen.blitz self.bg_image. And the position that that image will be drawn at is 0, 0. Self.screen.blitz self.bg_image. Okay, that looks good. That looks good. And finally, we're just going to have an update that occurs every tick. So game specific updates will just be self.scoreboard.update. And lastly, we'll just have our if name equals main game run. logic here. So this will happen whenever we'd run Python 3 main.py. Now, if we were to try and run this right now, we would get a ton of errors, and that's because we haven't actually configured a couple other things that we need. The first of which is going to be settings.py. So I'm going to basically just create a title string, which is going to be LED Scoreboard. And we're also going to need to have just a note that says each pixel is a 30 by 30 square. So if I did actual pixels, right, I mean the game would be very, very small. So for the sake of this demonstration, I'm basically just making each quote-unquote pixel a 30 by 30 square. And if we go back to this image, you'd notice that, like, if I tried to have a graphical representation of this, obviously each of these little LEDs take up, you know, quite a bit more than a single pixel, right? So I thought 30 by 30 pixels was a good number, and I'm actually going to have a graphical representation of what the LED looks like, which for us, it kind of just resembles, you know, kind of this little gray circle when it's off, right? And then, of course, it is illuminated when the LED is on. So we're going to have a graphical representation of that as our 30 by 30 square, which will look like this. But before we start creating those, I'm going to create a pixel height equals 32 and pixel width equals 64. So this is going to be that 64 by 32 board that we saw. And essentially what that means is we need a multiplier. And that's going to be pixel multi equals 30. So in order to get our height and width variables, which we basically set, or rather referred to here, we need to do some multiplication. We're going to take the height and width variables and multiply them each by our multi, and that will be our height equals pixel height times pixel multi, right? And that's going to give us 960. And then we're going to have our width equals pixel width times pixel multi, and that's going to give us 1920. So basically our resolution for our screen is going to be screen is 1920 by 960. And that is a 2:1 aspect ratio, which I think works well for this project. So then we're going to have a few images, bg image path, and that's just going to be in the graphics directory and be bg.png. And then we're going to have the off image, which is going to be basically the graphical representation of an LED that is not illuminated, and that's going to be graphics 0.png for lack of a better name. I'm going to copy this because I'm going to use it a few times. We're going to have a P1, player 1 image, and then we're going to have a player 2 image, and these are just going to be 1 and 2. And I think that is going to do it for our images. So we do need to create a new directory, and I can basically do that by, actually we can do that by hitting this folder here, graphics. And we need to create these files that currently do not exist. So the first thing is going to be creating a 1920 by 960 background, and I can do that by going to new 1920 by 960, and then I can just edit fill foreground color, and Control Shift Alt W will allow me to export this as PNG, and we can see it in the graphics directory. So the next step is to go back and actually have our off image, which again is going to resemble basically just a gray circle. So I'm going to one of these, I have 3 30 by 30, basically just squares here, and I'm going to fill them with the foreground color, and then I'm going to zoom in, and I'm going to go to a brush And this is actually perfect. And I'm going to create basically like a dark gray circle. And that is just going to be centered as best as I can do manually. That looks pretty centered to me. And now I can Control-Alt-Shift-W and save this as 0.png. Moving on, I will create a similar LED, but it's going to be on. So our player 1 color is going to be red, which means that I need to fill this with our foreground color and then zoom in. Using the same brush, which is the exact same size as the other one, we're going to try and get it in the exact same spot. I'm going to go to a nice blue color, and this looks good to me. And I'll go ahead and try and find the center again. And you could definitely be more precise with this. If you wanted to, you could probably just modify the other image and then change the hue and saturation of the layer, but I think that we can get pretty close by hand, and this looks pretty good to me. So I will save it as 1.png. And as you might imagine, we need to create a red. So I'm going to go ahead and edit, fill, zoom in, zoom out. There we go. Good enough. And I will find a red, and that looks good to me. Bring out the brush, and again, try and find a centered area. This looks good to me. Now, I also want a fully red and a fully blue pixel. And this is going to be when we actually create our tiles. So we'll get into that a little bit more later, but I'm going to actually create a full red. And I'll do the same for blue. Save this as blue.png. And while we're at it, we'll create one that's fully blacked out. So there we go. We have our representations of pixels, and that should get us to where we need to be to move on and create our scoreboard. So we see all of our image files here, and everything looks as it should. So I'm just going to minimize this. And we're going to go ahead and create a new file, which is going to be scores.py. And within scores.py, we're going to begin constructing our scoreboard class. We are going to leverage settings, so from settings, import star, and import Pygame as well. And while we're at it, this should be in main.py. And now those errors seem to disappear for the most part, except for scoreboard. So we'll go ahead and save this, and go back over to scores. And within scores, we're going to create our class scoreboard. And we're going to have an init function, def init, which takes self p1 score and p2 score, which were the variables that we basically added in main.py right here. So we're going to have quite a few things that we set up in the beginning in our init function. So bear with me while we get all of these, but we need to have a reference to our screen. So self.display surface equals pygame.display.get surface. Then we're going to have the P1 and P2 scores equal to integers of the same name. So self.p1 score and self.p2 score are going to be equal to int p1 score and int p2 score, respectively. And then we need to create a few surfaces. So we're going to have an off surface, which is just going to load the image of our off LED. And then we're going to do the same for the player 1 LED on and player 2 LED on. So those are the three surfaces that we're going to start off with. Self.off surface is going to be equal to pygame.image.load off image. And then we're going to convert that as best practice. And then we're going to do the same thing for self.p1 surf equal to pygame.image.load p1 p1 image dot convert alpha, and lastly self.p2 surf dot convert alpha. So then we're going to have our boolean self.can increment, and that's going to be set to true at first. And we're going to have our self.increment time set to none, because we're not actually incrementing just yet, basically when this gets initialized. Then we're going to have self.gameOver, and that of course will be false to start. And we'll have self.gameOverTime set to none to start. And finally, we're going to have self.winner set to none. So basically, all of these things will get referenced as the game progresses, and we will have some cooldowns that basically use these booleans and the timestamps as well. So before we get to that, we basically want to draw all of the LEDs, right? So if we wanted to go through and simply draw the off LEDs, we could do that, and I'm gonna do that actually, just so we get an idea on what this thing is going to look like. So yeah, we will have a draw self function, which we need the def. We need to define this function, so we'll have a def draw self. And I'm actually going to have two draw functions, but for now, we're just going to do this. And what I'm going to say is we need to have kind of a coordinate that we start drawing at, and that's going to be 0, 0. However, we're only going to do this in the event that there is no winner. So for now, I'm just going to have if not self.winner. That means that if this is none, then we'll go ahead and draw stuff. And this doesn't matter so much now, but it will here momentarily. But I'm basically going to say my x-coordinate and my y-coordinate are both equal to 0. So now what I can do is just create my off rectangle. So I'm going to create that with off rectangle equal to self.offSurface.get rect, and then my top left is going to be x, y. And then I'm just going to draw this to the screen. And I'll do that with self.displaySurface.blit, and then I'll and then just have the off surface referenced here, and then the rectangle. And so this will basically draw my very first off LED starting at 0, 0. So it's going to be in the top left corner of the screen. And if I did this right now, it would just draw the same thing over and over. And I actually think that it will give us an idea on what it looks like. So I need to have an update function really quick. We'll just have self here, and then I'll just have self.draw. And I think I should be able to run this. So I will open a PowerShell window and Python main.py. And I need to actually be able to reference this. So I need a from scores import star. Actually, we can just do import scoreboard. So I'll try that again. And I think it actually drew it once and then drew the BG image over it. So let's see why that happened. So I forgot two very important lines in the display, which of course is the tick and the display update, which basically continues to draw this for as long as the while loop is true. So basically we also need an FPS variable, which is in settings.py, and I have set that to 120 frames per second. So everything should work now, and we will give it a try. Alright, so we get a couple errors here that are basically about an incorrect sRGB profile, and we can fix that with the mogrify command, which I will do later. But we can basically see our one lonely off LED right here in the top left corner. So we're going to go ahead and draw this out on the entire screen, and I can do that by basically adding 30 to our X value, because remember, these are 30 by 30. And so if I want to draw another one at the position 30, 0, then the X value needs to basically be incremented, right? So in order to draw this across the screen and all the way to the bottom right, we would basically need some type of loop here. And so I can have a for I in range, but then I would need to know how many pixels there are. And of course I can calculate that by doing 64 times 32. So that is 2048 total pixels. And basically what I can do is say for I in range 2048. And then I can have this here. And then I can also do X, basically have an if statement. If X is greater than 890, then set X to 0 and Y plus equals 30. So now if we run this, basically what's going to happen is if we get over to 920, actually this needs to be 1890, sorry. So if we add 30 to X when it's at 1890, of course it's going to end up being greater than 1890. It's going to be 1920. And that means we've reached as wide as we want to go. So we're going to reset our X value to 0. And then we're going to add 30 to the Y value. So once we've basically drawn our off LED, the width of the screen on our very first row, then basically we're going to jump 30 downward and restart at this value. So it might be hard to like gauge what that looks like in your head, and this actually should be under the if statement. And after each time that we draw this, we do need to increment the X value by 30 as well. So X plus equals 30. So now we do have our 2048 pixel LED scoreboard. Of course, this is a bit boring because we're not actually drawing any numbers, and thus the scoreboard is, useless at this point. Now, I do have the ability to hit the A and F keys, and they are actually incrementing the score, but we don't have any logic that draws those numbers out to the screen. So let's go ahead and work on that now. It is easiest to start with 0, of course, so I'm going to go ahead and do that. But at this point, I'm going to create two functions, and they're going to be draw P1 and draw P2. So instead of just having this nice, concise code, it's going to get kind of ugly, and I could probably combine these functions in some way, but for the purposes of this video, I just separated them, and there's a lot of copy and paste code, unfortunately. But we're going to go ahead and have a self.draw P1 and a self.draw P2 in our update function, which means that this needs to be draw P1, and we'll go ahead and have a draw P2 right beneath it. And for right now, this will just be pass. And what I'd like to do is just have my 0. So what does a 0 look like? That's a good question. This is an application called Tiled. in which I have basically created a tile map with a 32 by 32 square, and I have created a series of numbers 0 through 9 in order to keep track of our score. And so this to me looks like a decent enough 0. And what it allows me to do is output this to a series of numbers, which I can basically use in Python to determine which of my pixel images I'm going to draw, right? So there is a reference for this black pixel, and it is a number. There's also one for red, and it is a number. And we will see that here in a moment. But I've basically done all of the work here so you don't have to. If you wanted to create your own numbers because my quote-unquote font is a little ugly or whatever, or you think that you can do a cooler looking 3 or 4 or 5, I would recommend that you take a look at the application tiled. But me actually doing this by hand was a bit cumbersome, so I decided to basically just leave that up to you. And I've provided the numerical outputs of each of these in the GitHub repo, or rather I will once this video is done recording. But yeah, basically I wanted to show you what that looks like numerically. This 0 right here is a series of numbers that I can basically reference in order to print out. And again, a 1 in my case, and you can actually see the highlighting here that it creates this nice little 0. So basically my logic is going to be to iterate through this list, and if I see a 1, I'm going to have my off LED, and if I have my 2, it's going to be my on LED. And this is actually a really nice kind of convenient way of determining which image I should be drawing to the screen. So I have my 0 through 9.tmx files, which are basically just XML, right? And they give me this nice little list here. And again, if you highlight that, you can vaguely see the 0. And this works for all of my 0 through 9 images. So basically, I have created this in a file called pixels.py. And I did this previously, and I am not going to redo it because it took like an hour at least. So I'm basically just going to copy this file, and I am going to append that to my directory here as pixels.py. And we're just going to start with 0, and I have a W as well that basically is going to print out if someone wins, but we'll get to that. At the very first kind of pass at this, I just wanted to print out a 0 to 0, right? So we basically have a dictionary, and then it has our number 0. And so if I did LED numbers at 0, I would just get the value, which is this giant list. So I'm going to go back over to scores, and basically what I'm going to do here is change my logic up in my draw P1. And we're going to leave it as if not self winner, but then I'm going to have basically a bit different logic here. I'm just going to go ahead and get rid of this, even though a lot of it will be the same. I'll leave this down here because this is actually, I'll cut this because I'm going to use that here in just a moment. But basically what I'm going to do here is I'm still going to set my X and Y 0, 0. And then I'm going to have 4 pix in LED numbers self.p1 underscore score. All right, so this is going to get my numerical score. And I do actually need to import pixels. So from pixels import star. And now I can reference that LED numbers dictionary in my pixels.py file. And what I'm going to do is basically have my if x is greater than 930. We're going to set x to 0 and then increment the y value, which is pretty similar to what we did previously. And I'm going to have a couple if statements. If pix equals 1, right, we go back over to this list, and basically this is 1. That is off. 1 is off in this case. So if pix equals 1, then I'm going to create a specific rectangle, right? And that rectangle is going to be based on the off surface, very similar to what we did previously. And I'm going to increment the x value by 30. So then I need some logic for elif pix equals 2, right? And in that case, we go back over to our Notepad++ and highlight 2, right? Then we want to basically have a different image, which, as you guessed it, is going to be our LED on for player 1, which I believe we decided was going to be blue. So the way that I would do that is p1 rect equals self.p1surf.getRect, and our top left will be equal to our x and our y value. And then we'll have a self.display surface.blit, self.p1 surf, and p1 rect. And then we'll add 30 to the x value. Now I should be able to print this, and it should actually give me player 1's score. And there we go. We actually have our 0. And I think I can actually increment this because it only lets me increment it once. Okay, so our cooldown function is not implemented properly at this time, but at least you saw that we could go from 0 to 1. And again, that is referencing these maps that we have in our LED numbers, courtesy of the output of tiled. So now, of course, it is time to modify our draw p2 function. And again, this is kind of where we get to the point where it's like, I could have most likely done this in the same function and thus not had to do this really dumb thing where I copy and paste, but we're going to go ahead and just do it anyway. So I'm going to go ahead and Control D this and basically highlight all the instances of P1 and change them to P2. Now, other key differences here are that P2 is on the second half of the screen, or the right half of the screen, which starts at 960 for the X value. And then we also have a different check, which instead of 930, we're going to have 1890. And then we want to change this back to our origin of 960, as you see here. And I believe that should do it. Of course, we need to make sure that our P2 surface is set to a different color, and I think it should be. Let's give that a go. And it is. So now I can increment the left side and the right side. Actually, no, our cooldown prevents us from incrementing either once I do that. But I'll go ahead and restart this and try and increment the right side, and you can see that that works as well. So our scoreboard is actually starting to look pretty nice. Of course, there is some missing functionality. We also continue to get this right here, which is super annoying. So I'm going to show you a quick trick in the terminal, and that is just mogrify, I believe it is, star graphics star.png. That doesn't look like it did much, but if I run this again, I don't get those errors anymore, which is nice. So let's go ahead and move on. We are missing a cooldowns function. So that will be up here, def cooldowns. And every time we run this, which of course is every tick, we need to get the current time. So current time will be equal to pygame.time.getTicks. And basically what we're going to do is check right here for our ability to increment. And if we don't have the ability to increment, we basically need a cooldown timer to go into effect. So we'll have if not self.canIncrement. So when we were basically trying to run this before, can increment gets set to false. Of course, we're not having a cooldown that sets it back to true, right? So that's kind of our current bug. So we'll have if current time minus self.increment time is greater than, and I can have this be, I don't know, 1,000. I believe it's 1,000 milliseconds, which is 1 second. Then we'll just have self.canIncrement set to true. So let's see if that works. Of course, I need to run cooldowns, self.cooldowns, and then we need to run this here. And this should be a subtraction symbol. So I'm pressing this over and over, as you can hear, but there definitely is like a 1 second delay before it allows me to do that. So that delay to me is acceptable, and it basically prevents someone from just spamming the button over and over again. So we also need another cooldown, which basically is going to check if the game is over. And we haven't really talked about what it means for the game to be over, but that is going to be when the player gets 10 points, right? So we start at 0, 9 is the highest, and basically if someone's score goes over 9, that means that they won. So we're going to print out a win screen when that happens. Of course, we'll talk about that in just a moment. And for now, we'll deal with the cooldown, which will be if self.gameOver, if current time minus self.gameOverTime is greater than 1000. Again, I think that's a good number. We'll reset the scoreboard. And basically, that's just going to be doing all of this stuff again and setting the score to 0, 0. So I'm going to copy this. And then I'm also going to self.p1 score and self.p2 score and set those to 0, 0. And then just paste this here. And that essentially is resetting the scoreboard. And now we need to implement our winner logic, and that's going to be in a different function. And that will just be def check for winner. This is really simple. We're just going to have if self.p1 score equals 10, then we will declare the winner, self.winner equals p1, and then we'll have self.gameOver set to true, and then we'll have our self.gameOverTime variable set to pygame.time.getTicks, and lastly, we'll have our self.canIncrement set to true. Actually, I don't think that's necessary, so I'll remove it since it is already in our game over cooldown. So then I can also have an elif self.p2 score equals 10 and basically do the exact same thing. So much so that I can copy and paste this in, but change this to p2. So now you'll probably be wondering, okay, what do we do when we have a winner? Well, we're going to change the way that we draw the LED screen, and I'm basically going to take my really ugly W, which is either blue or red, right? So basically if the, well, we'll run this, and basically if red gets to 10, we're going to print a W. Now let's see what happens right now if we get to that 10. It just dies because we don't have anything. There's no key for 10, right? So what we need to do is create an elif statement right here. So basically I'm going to have this be a draw win screen, and what color? So it's going to be blue. So we'll have P1 be draw P1 win screen. So we basically need to have elif self.winner. That means there is a winner, right? Because we have this if not self.winner. So if elif self.winner and self.winner equals P1, then we're going to, and this is kind of messy because we're basically doing a lot of similar logic here, but we're basically going to have the x, y set to 0, 0 again. And then we're going to do a different for loop. For picks in LED wins. And then the index, of course, will be the self.winner, which in this case would be P1. We're going to check if x is greater than the 1890, which it will be at 1920. And if so, we'll reset that to x equals 0. And we will add 30 to the y value. Then we're going to check. We're basically going to look at our values for the w, right? Which again, this is basically just numerical. There's going to be either a 1 or a 2. So basically we're going to have that be if pix equals 1. And then we will have our off rectangle equal to self dot off surface dot get rect top left will be equal to xy. This obviously looks very familiar. And then we'll just do basically the same exact thing right here. And then otherwise, lf pix equals 2. And then literally a copy of this. And we should be able to do the very same thing in draw P2. But we will, of course, add a comment, which will just say draw blue P2 windscreen. And we'll change all of these occurrences to P2. And just for testing, I'm actually going to drop this down to 100 because it prevents me from very quickly going through the score. So we do have a bug that's basically saying key error 10, right? Because that is still incrementing. The root of the issue is that we're not actually calling our check for wins function yet. So we need to add this self.check for winner. And let's give that a shot. Okay, we can quickly get up to 10, and there we go. There is the W. So, as you can see, we're kind of stuck on the win screen, so our cooldown is not working properly just yet, but at least we do get to the win screen. So let's take a look. In our cooldowns, we basically have some logic that is a cooldown for when the game is over. So let's see what that looks like. So if our current time minus our game over time is over 1,000 milliseconds, then reset everything and set the winner to none. So when we go back over to main, we need to get rid of this actually, because we do want to listen for key events. So let's go ahead and rerun this. And the way that this will work is that the winner, and right now you see that I'm not pressing anything, you hear that I'm not pressing anything. If the winner wants to continue the game, he basically, or she basically, has to push the increment button on their key, which in this case is A. So if I press that, it will reset the game. And conversely, if the red player wins, oh, we have a bug with the red player. Let's see why that occurred. All right, let's go back down to draw P2. If self.winner and self.winner equals P2. So I'm actually, this is one of those things where I could not copy and paste this value, because remember, in tiled, I mentioned that we have a black, a blue, and a red. So blue actually has a different numerical value, and that is 3. So I need to check for if pix equals 3. Now this is one of those things that, like, I probably could have just used zeros and ones if I wanted to have like 0 be off and 1 be on. But based on the way that tiled outputted these large numerical strings for our numbers, it just ended up being 3. So let's go ahead and try and run that again and have the player 2 win, and there we go. So now it will stay here until player 2 increments, and then of course we will get back to our screen. And that is really it. This is essentially how you would draw to an LED screen, and basically dividing it in half so that you have the score for 2 different players here. And I imagine if you were to get one of these adafruit screens, there's probably something that does this for you, but if you really wanted to implement it by hand, that is how you could do it. So I know that this video probably got quite a bit longer than I imagined that it would, but I'm hoping that it was informative, and if you have any questions or comments or anything like that, please leave them in the comments. And of course, feel free to like and subscribe as well. Thank you so much for watching, and I will see you in the next one.